वेलकम टू माय यूट्यूब चैनल मदन अनंत मैथमेटिक्स। आई होप आपने मेरी दोनों वीडियोस जो मैंने पहले इसी टॉपिक पे इन्वर्स ट्रिग्नोमेट्री पे बनाई है ज़रूर देखी होगी। इसमें हम इन्वर्स ट्रिग्नोमेट्री फंक्शंस पर जो नेक्स्ट सब टॉपिक है प्रॉपर्टीज़ ऑफ इन्वर्स ट्रिग्नोमेट्री फंक्शन वो डिस्कस करेंगे। द फर्स्ट प्रॉपर्टी इज साइन इनवर्स 1 by x is equal to cosec inverse x for all x belongs to r minus open interval minus 1 to 1. Cosec inverse 1 by x is equal to sin inverse x for all x belongs to minus 1 to 1. Cos inverse of 1 by x is equal to sec inverse x for all x belongs to r minus open interval minus 1 to 1. And similarly we will have another three properties you can see on the screen. Sec inverse 1 by x is equal to cos inverse x for all x belongs to minus 1 to 1. Tan inverse of 1 by x is equal to cot inverse x for all x greater than 0. Cot inverse 1 by x is equal to tan inverse x for all x greater than 0. I will prove one of these and you can prove other because they all have similar proof.
So let's start with the proof of cos inverse 1 by x is equal to sec inverse x for all x belongs to set of real number minus open interval minus 1 to 1. So let sec inverse x is equal to y. Applying sec on both sides, we will have sec y is equal to x. Sec y can be written as 1 by cos y, so we have 1 by cos y is equal to x. Interchanging their position will give us 1 by x is equal to cos y. Applying cos inverse on both sides, we will have cos inverse 1 by x is equal to y, and y is equal to sec inverse x as we assumed in the beginning. So we have cos inverse 1 by x is equal to sec inverse x for all x belongs to set of real number minus open interval minus 1 to 1.
So you can prove other yourself. The next property is sin inverse of minus x is equal to minus sin inverse x for all x belongs to minus 1 to 1. The same property holds for tan inverse and cos inverse x in their respective domains. Next we have cos inverse of minus x is equal to pi minus cos inverse x for all x belongs to closed interval minus 1 to 1. Cot inverse of minus x is equal to pi minus cot inverse x for all x belongs to R. Sec inverse of minus x is equal to pi minus sec inverse x for all x belongs to R minus open interval minus 1 to 1. I will prove two of them and rest you can prove yourself as they all have similar proof. So first of all I am going to prove tan inverse of minus x is equal to minus tan inverse x for all x belongs to R. Let us suppose tan inverse of minus x is equal to y. Taking tan on both sides, we will have tan y is equal to minus x. Next we have minus tan y is equal to x. As we know, tan of minus y is equal to minus tan y. Using this property, we have tan of minus y is equal to x. Taking tan inverse on both sides, we will have minus y is equal to tan inverse x. Shifting negative on the another side, y is equal to minus tan inverse x, and y in the beginning we assumed tan inverse of minus x. So we will have tan inverse of minus x is equal to minus tan inverse x for all x belongs to R. I hope आपको ये समझ आया होगा. The next property हम यहाँ देखेंगे sec inverse of minus x is equal to pi minus sec inverse x for all x belongs to R minus open interval minus 1 to 1. So जैसा भी मैंने पिछले क्वेश्चन में या पिछली प्रॉपर्टी में डिस्कस किया स्टार्ट किया प्रूफ वैसे ही यहाँ पे भी करेंगे. They all have similar proof. So let us start with sec inverse of minus x is equal to y. This will give us sec y is equal to minus x. Shifting negative on another side will give us minus sec y is equal to x. Using property of sec function, sec pi minus theta is equal to minus sec theta, we will have sec of pi minus y is equal to x. Pi minus y is equal to sec inverse x using inverse property. Interchanging the position, we will have y is equal to pi minus sec inverse x, and in the beginning we assumed y is equal to sec inverse of minus x, so we will have the result. I hope आपको ये भी समझ आया होगा. So similarly you can prove rest of the two based on the same thing. The next property is sin inverse x plus cos inverse x is equal to pi by 2 for all x belongs to closed interval minus 1 to 1. Tan inverse x plus cot inverse x is equal to pi by 2 for all x belongs to R. And sec inverse x plus cosec inverse x is equal to pi by 2 for all x belongs to R minus open interval minus 1 to 1. I will prove one of these three and the rest of the two you can prove yourself. So I am going to prove this property tan inverse x plus cot inverse x is equal to pi by 2 for all x belongs to R. So we'll start with considering tan inverse x is equal to y. This will give us x is equal to tan y. Writing tan in terms of cot using the property that cot pi by 2 minus y is equal to tan y. Then we taking cot inverse on both sides, we will have cot inverse x is equal to pi by 2 minus y. Substituting the value of y as tan inverse x and shifting to the left hand side, we will have tan inverse x plus cot inverse x is equal to pi by 2. So we are done. So proof बहुत ज़्यादा complicated नहीं है, बहुत easy proof है. So similarly you can prove other two properties of the inverse trigonometric function. The next property is tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy whenever xy is less than 1. Similarly for negative we have another relationship. See where here we have different condition. If xy the product is less than 1, if product is less than 1, then we have this relationship. If product is greater than 1, then we have this relationship. I am going to prove this third one. Rest of the two you can prove yourself, and there is nothing to prove in the second one. If you prove first one, then you can just replace y with minus y to get the second relationship. So I am going to prove third relationship only. You can prove first yourself. So we are going to prove this property of tan inverse function. So let tan inverse x is equal to theta and tan inverse y is equal to phi. This will give us tan theta is equal to x and tan phi is equal to y. Now consider tan theta plus phi. From class 11th you already know tan theta plus phi will be equal to tan theta plus tan phi upon 1 minus tan theta tan phi. Now as we all know, tan theta is equal to x and tan phi is equal to y. You can substitute here. You will have x plus y upon 1 minus xy. Now let us discuss these conditions, why it is given, what is the importance of these conditions. So as we all know, x and y both are greater than 0. This will give us tan theta is greater than 0 and tan phi greater than 0, as x is equal to tan theta and y is equal to tan phi. अभी हमें पता है कि जो हमने ग्राफ देखे थे, मैंने अपनी पिछली वीडियो में बताया था, इन्वर्स एग्जिस्ट करने के लिए हमने इसके डोमेन को रिस्ट्रिक्ट किया था, कहाँ से कहाँ तक, माइनस पाई बाई टू टू पाई बाई टू, और ग्रेटर देन जीरो कहाँ से कहाँ रहेगा, सिर्फ 0 टू पाई बाई टू रहेगा. इट मीन्स थीटा इज ग्रेटर देन 0 लेस देन पाई बाई टू and phi is also greater than 0 less than pi by 2. You can add both of these inequalities. You will have theta plus phi is greater than 0 and less than pi. It means theta plus phi belongs to open interval 0 to pi. इसको हमने a equation suppose कर लिया. Let us discuss another inequality xy greater than 1. एंड हमने अभी पिछली स्लाइड में प्रूफ किया था कि tan थीटा प्लस फाई इज इक्वल टू x प्लस वाई अपॉन 1 माइनस एक्स वाई. As we all know, x and y both are positive, so numerator will be positive, and xy is greater than 1, this one is greater than 1, so 1 minus xy will be less than 0. Ultimately this whole fraction will be less than 0. Now we can see tangent value of theta plus phi is a negative number, means tangent value is negative. हमें पता है tangent function जो है वो सेकेंड एंड फोर्थ क्वाड्रेंट में नेगेटिव होता है. इट मीन्स थीटा प्लस फाई लाइज इन सेकेंड और फोर्थ क्वाड्रेंट. So let us consider this statement as statement number B. Now from statement A and B we can see theta plus phi will lie in second quadrant. यहाँ हम देखेंगे 0 to pi में क्या फर्स्ट एंड सेकेंड क्वाड्रेंट आ रहा है. यहाँ पे हम बता रहे हैं सेकेंड एंड फोर्थ, तो दोनों का जो कॉमन पार्ट होगा इट विल गिव अस थीटा प्लस फाई lies in second quadrant. By second quadrant we mean theta plus phi is greater than pi by 2 and less than pi. Now I am subtracting pi from this inequality. Less than theta plus phi minus pi, less than pi minus pi. Simplifying you will get minus pi by 2 is less than theta plus phi minus pi less than 0. Now I am going to consider tan theta plus phi minus pi. Taking negative common from this and using the property tan of minus theta is minus that theta. So this will give us minus tan pi minus theta plus phi, and we know tan pi minus theta is minus tan theta, so double negative will make it positive, so we will have tan theta plus phi and that is x plus y upon 1 minus xy. ये मैंने पहले प्रूफ किया है अपने जब इसका प्रूफ स्टार्ट किया था. So taking tan inverse on both side, it will give us theta plus phi minus phi is equal to tan inverse x plus y upon 1 minus xy. Shifting pi on another side and substituting the value of theta and phi जो हमने स्टार्टिंग में सपोज की थी, that is tan inverse x plus tan inverse y. So we have tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y upon 1 minus xy whenever xy is greater than 1 and both are positive. I hope आपको ये समझ आया होगा. The proof is little bit lengthy but quite interesting. Next property देखते हैं हम. 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square when x lies between minus 1 to 1 open interval. Similarly we will have these two identity. See left hand side आप देख सकते हैं सबकी सेम है, 2 tan inverse x का ही फॉर्मूला है. but they are in terms of tan inverse, cos inverse and sin inverse. तो आप जैसा भी क्वेश्चन की रिक्वायरमेंट हो गई हम उस के अकॉर्डिंगली ये फॉर्मूले यूज़ करेंगे। इन फॉर्मूलों को याद रखना, थोड़ा सा लिंक बनाएंगे आप क्लास 11 से, तो ईजी है बहुत। जैसे अगर आप याद करेंगे tan टू थीटा का जो फॉर्मूला होता था वो होता था 2 tan थीटा अपॉन 1 माइनस tan स्क्वायर थीटा। cos टू थीटा का फॉर्मूला इन टर्म्स ऑफ tan थीटा इज 1 माइनस tan स्क्वायर थीटा अपॉन 1 प्लस tan स्क्वायर थीटा, एंड sin टू थीटा इन टर्म्स ऑफ tan थीटा इज 2 tan थीटा अपॉन 1 प्लस tan स्क्वायर थीटा। तो आप वहाँ से भी लिंक बना सकते हैं और यही इनके प्रूफ में भी आपको हेल्प करेगा। आई एम गोइंग टू प्रूव दिस फर्स्ट वन, 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square whenever x lies between minus 1 to 1. As I discussed earlier, the first property जो भी इससे पहले वाली स्लाइड में दिखाई थी, tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy whenever xy is less than 1. I am going to replace y with x. So we will have 2 tan inverse x is equal to tan inverse x plus x upon 1 minus x square. On simplifying, you will get tan inverse 2x upon 1 minus x square whenever x square is less than 1. And x square is less than 1 will give you x greater than minus 1 and less than 1. So we are done. An alternative proof. So let's start with considering x is equal to tan theta and substituting on the right hand side. You will have tan inverse 2 tan theta upon 1 minus tan square theta. अभी मैंने पिछली स्लाइड में भी बताया था कि this is nothing but the formula of tan to theta. This will be tan inverse tan to theta. So this will give you 2 theta by definition of tan inverse function, and that is equal to 2 tan inverse x as written here. So we are done. आप बाकी के प्रूफ खुद से कीजिएगा। थैंक यू सो मच। अगर आपको ये वीडियो पसंद आई तो आप मेरे चैनल को सब्सक्राइब कीजिए ताकि आने वाली वीडियोस की नोटिफिकेशन आपको मिलते रहें, और अपने दोस्तों के साथ शेयर कीजिए, इस वीडियो को लाइक कीजिए। थैंक यू अगेन।